Hello, my name is Rajat Talesa and welcome to another video on my YouTube channel. So this video is really important for all those who are in college, who are pursuing some degree in computer science, and especially for those who are between 2 to 5 years of experience, because nowadays companies are having a specific round for system design architecture, okay, or high level system design. So this video is for those guys. I have created this video in such a way that from start to end, anyone who has basic knowledge of computer science or even the advanced knowledge of computer science will learn something new in it. Okay, so please, I would highly encourage you to view this fully. Now, let me give you some context. Okay, so on this Sunday, there was a AWS meetup in which I was one of the guest speakers. So the topic that I chose was related to architecture and excellence, basically creating highly scalable systems with AWS. Okay, the reason for this topic was that I wanted to include such a topic where college students as well as professionals who come in these meetups both can benefit from it. Okay. At the same time, this is my personal experience that if in these meetups, if there is something related to code, it works only for those who have some experience in that particular coding stack. So I was not comfortable giving a code related thing because it doesn't include everyone. I wanted to do something which includes everyone. And the response was really, really good. All the participants appreciated how the overall presentation was. Okay, so let's go and deep dive into what the presentation was. I'll explain you everything in detail from very basic. Okay, and in the end, it will become really hard. So please keep up. Okay, the best way to follow this presentation is once I start the presentation, you should keep a pen and paper with you and try to, I'll be drawing diagrams in this. So try to draw those diagrams on your own also. Okay, that would give you the best experience. Otherwise, if you just watch it or just hear it, then also it's fine. Okay, so let me close this. Now let me start the presentation. Okay, so this was my presentation. Basically, here was AWS logo and I changed it for this video. So architecture, scalable systems, excellence, basically building high performance AWS systems. So let's go. Okay, what was the agenda for the entire session or entire presentation? Introduction to the session, terminology and expectation, basic expectation that these are the things that you should know. Digital brainstorm, this is the major time, like 80 to 90% of my presentation went into this time. And finally, summary and conclusion in which I'll do the revision basically. Okay, so about me, I am a software engineer, senior software engineer with 8+ years of experience. I have experience in Android, Ruby, React, Rails, and many more other technologies. I've worked with many startups, and the prominent companies that I've worked with are Google, Dev.to, Gumroad. These are some good companies that I've worked with. The plan of this entire presentation is to build highly scalable systems and introduction to AWS services also. Okay, so this is useful for people who are mainly want to learn computer science to depth, create highly scalable products. At the same time, someone who is in the process of joining other teams, going through the interview process, this is helpful for them also. So let's start. Okay, so basic terminologies. First is database, second is client, third is server, and fourth is API and request. So these are the basic expectations that I have that you understand. Even if you don't, I will give you a quick review. For example, on WhatsApp, you are sending a message to your friend. Okay, as soon as you send this message, your friend receives it, for example. Okay, now in this entire process, what will happen is you are the client. Okay, I'm the client here. I'll send a message. It will go to the server, which is a central CPU or central laptop from WhatsApp. Okay, saying laptop because that's the easiest interpretation for anyone. Otherwise, we general terminology is server. That server is responsible for making sure that the message is from the correct person. At the same time, it is responsible to send that message to the correct person. Okay, so that's two. And third is it will make sure that it can save it somewhere. So saving it somewhere is called database. So database is a disk storage generally where we save details. Okay, so client is me, server is all the logic central to which all the users are getting connected, and database is the final storage where things are getting stored. Now, whenever my friend will open his or her application, they will receive the message via server, and the server will fetch that detail from the database. Okay. Now, this entire communication, like when I sent the message and it went to the server, this is called request response thing. I sent my message using an API basically. Okay. So let's start. This was the icebreaker, but for you guys, it's fine. If you want to answer these questions in comment, it's fine. Okay. Basically, to set expectation and understand the overall audience in my session that who have what type of knowledge or skills basically. Okay. So now let's start. This is the basic system. Okay. Let's understand this first. So assume I have created any application, let's say WhatsApp only. Okay. Which is capable of sending messages, receiving messages and all those kind of things. So if I am a new developer, there is no other team or anything. I'll generally what I'll do is I'll create the product. It doesn't have many users because I recently created it. I'll host it somewhere. Okay. So that hosting is done on servers, basically a computer which is alive generally all the time, not technically, but generally all the time. It is alive and other people, other users can connect to it to send and receive servers. Okay. So how it will work is I'm the client. I'll send the message. It will go to the server. It will do some logical thing. Okay, it is from the correct user to which user I have to send it, all those things, and it will save that information to database. That's one. Second, if I am a user who wants to receive messages, I'll send that. Technically, it doesn't happen like that, but let's assume I'll send that information to server that, hey, fetch those details. That detail will again go to database, fetch details, get back to server and get back to client. Technically, it doesn't happen that advanced developers can understand this, but I'm giving you a very basic overview that this is how client or any number of users, it can be 100,000, any number of users communicate with the server. In this case, it is only one single server and it communicates with the database, which is another single. Okay. So if you are using AWS, you can use EC2, which is basically a server or a computer which Amazon provides, AWS services provides, where you can do commutations. Okay. Now, this entire thing is an example of monolithic architecture. Okay. What it means is that there is only one single code base, one single thing which is handling everything. Okay. In this case, this is the server. Okay. Now, the advantage of this entire structure is it is very easy to manage. Okay, you don't need very good capabilities. You just need basic skills and you can manage it easily. Okay, so that's the advantage. There is one very big disadvantage. For example, your computer crashes. That's a very common problem, right? Similar to that, I have been saying that server are also computers only. So what if this computer, which is the server, crashes? What will happen? Will this client be able to communicate with database directly? No, there is no connection between them. So if this server is dead, it crashes, your entire system fails. No one will be able to send messages. No one will be able to receive messages. So this is the biggest disadvantage of monolithic architecture. If something fails, the entire product fails. Okay, and this is called as single point of failure. Okay, so we'll look this up in more detail later on. What is single point of failure? Okay, or maybe I can explain you right now and I'll skip later. So single point of failure means that this system is dependent on one single point in such a way that if it fails, entire system crashes. So that's called single point of failure. Okay, let's go to next one. Okay, so this is the problem that I gave, right? What if the server crashes similar to our laptops? If it crashes, entire system fails. We know that. Now, how do we solve it? So the simplest solution is, for example, I'll give you one example. Android developers might be able to relate to it. So what happens is when we are doing development in Android applications, it requires minimum 8 GB of RAM. Okay. Now, back in 2016, 2017, I was not rich enough to or capable enough to buy MacBook or any of those high-end products. So I had a laptop, very simple one. Now, the problem with that kind of laptop was that as soon as I ran Android Studio, it would crash sometime. Okay. So the basic solution in that case was to get a better machine, maybe a MacBook, which will not crash. So this is basically what I'm saying, that if our server is crashing, what we can do is we can increase its own capacity. We can increase its own RAM, CPU units and all those things. Okay. This is called vertical scaling. Okay. Basically your same system, but you are improving its overall specifications. Okay. That's one, but that is limited. You cannot go beyond. If you think of any laptop also, I'm telling you laptop, not a custom computer, but if you think of any laptop, you will be able to think of maximum 5 lakh INR laptop. Okay. Maybe a bit beyond that. I am not aware of that, but there is a limit to it, right? You cannot keep on putting money and assume that you can get a better PC. There is a limit to that. So there is an alternate solution, which is a better solution. Vertical scaling is not the good solution. Okay. If your machines are good enough, you should go for horizontal scaling. What it means is that, for example, this is my laptop, which is doing some heavy computations, running 3 to 4 applications. What I will do is I'll use another laptop run two of my applications on that and run two of my applications here so that I can use both the resources correctly. At the same time, my overall work can be done. Now, this is called horizontal scaling, which means that you buy a similar server. So let's go to that. Now, if you are doing this on paper pen, you can follow this system. What I did was I created another server. This is in pink is something that you have to focus on. Okay. So I have created another server. Now comes the problem. How will this client know whether it should communicate with this server or this server? Basically, I have mentioned two servers here, but there can be n number of servers, 5, 10, 15, 100, whatever you want. Okay. But the point, main logic is that if there are more than one server, how will the client know which server they have to communicate with? That's one. Okay. Now, let's assume we are giving some random logic to this client that they can communicate with this server. Okay. If it keeps on communicating with this server, even if we have the second server, it won't get any load, it won't get any request, it won't get any clients. So this one is still overloaded, this one is not. For example, if you are having a team project of 5 people, someone who is doing really hard work will keep on getting more and more work, and someone who is not interested in doing work will not get any work. Okay. So the work overload is not managed between all the team members, right? That's a common problem. So for this, the first solution which comes is load balancing. Okay, how we will use it, I will explain you. But till this point, we have learned two major terminologies. One is monolithic architecture, which means entire project in one single thing, and if it fails, everything fails. So the solution for that was breaking into multiple parts using multiple servers. Okay, now we need a load balancer. This is a second terminology. What is a load balancer? It will balance the load between various servers. Let's see how. So we have introduced a load balancer. Now client will just communicate with load balancer, nothing else. Okay. Now this load balancer has information about all the servers, 1, 2, 3, 4, 5, 6, whatever it is. It has information about all the servers. In this case, there are only two servers. So what this load balancer will do is it will give first request to this, second request to this, third, fourth down, fifth up, sixth down, seventh up, eighth down, ninth up, 10th down. Now, out of all those 10 requests, 5 went to server 1, another 5 went to server 2. So the load was balanced. This is the main logic of load balancer. It will balance the load between various servers. How it will do that? There are various algorithms to it. I have read at least 5 types of algorithms to it. I won't communicate to this about that in this video, because if you like this video, if the response on this entire video is really great, then I'm thinking of creating like 25 to 30 hours of content about high-level system design, going in depth of each and everything, but only if I get good response on it. If I don't get good response, I won't do that because it requires a lot of hard work. I have all the notes and everything actually ready. This is an entire, sorry, not half, but this is an entire book covered with high-level system design notes and a much more things. But basic point is that somehow, based on some logic, this load balancer will distribute the load among various servers. Most general algorithm is round robin. If you don't know that, right now I cannot cover that up. If you are interested in that, do comment. So what is load balancer? Distributes request across multiple servers. We saw that. Balances load among servers. We saw that. It was making sure that first server got 5 requests, second server got 5 requests. It was not like first got 8 requests and second got 2 requests. Okay, so it is managing the load also, balancing that also. It can be used anywhere in the architecture. For example, right now we used it between client and servers. Client was this and server were these. So we used it here. In future, we can use it between servers and servers and database at various other places. Okay. So load balancer can be used at various places in a database. Okay. In a entire system. Let's go. What are the pros of load balancer? So if you remember earlier, we had a single point of failure. That was if the server in our first case, if this server failed, the entire system failed, right? Now let's see. In this, what if this, first of all, if there are only two servers, then also it's highly unlikely that both the servers will fail at the same time. Okay. For example, if you are someone who has more than two light bulbs in your room, there would be hardly a case where two light bulbs will fail at the same time. Only one will fail mostly, right? So that's how servers also work. But even if that's the case, generally we don't have two servers, we have more than that. Okay. So we can assume that out of all these, any one of them can fail at any point, but not all of them will fail. Okay. That's a very basic assumption. It's not a big deal. and it is really easily achievable also. So for example, if this server fails, now that information will get to load balancer, and what this load balancer do is, after that point, all the requests will get routed to this server only, and it will notify whoever is the system architect that, hey, please make sure that this server is working. So they can fix this server in that meantime. And now again, this load balancer will balance both of these loads. Now in this system, temporarily for a moment, this second server got a lot of load, which is fine. But did the system fail? No. Client was still able to communicate with the database and got all the information. That's what we want. That's what make load balancer, using load balancer, that is the pro, that the system is highly available. It is available all the time. It will rarely crash, and it is therefore it becomes highly reliable also. Okay, that's one. What are the cons? What if this load balancer itself becomes a single point of failure? What if this load balancer itself fails? Okay, because right now also, if this load balancer fails, this client won't be able to communicate. Okay, so in this case, what we have is something, there are various strategies, again, 4 to 5 different strategies, but one strategy I'm telling you is that we can have two types of load balancer. One is active load balancer, second is passive load balancer. So active is the one which we are using, but if this dies, the passive one will automatically become activated. We can write that algorithm to make it so. So in that case also, we do have second backup to make sure that requests do work. Okay. So that's why when we are using load balancer, we don't worry about it a lot, because we can always keep a passive load balancer to fix it. There are other strategies also, but for now this is fine. Okay. How does it work? In our case, I did up, down, up, down, up, down, which basically means route robin. There are other 4 different types of algorithms also. I'm just mentioning name of some: source, IP hash, least connections. 3 of them are static, 2 of them are dynamic algorithms, all those. So if you want details, do let me know in comments and I'll create videos. Okay, so that's the first part. Now, what if the server still gets overloaded? For example, the server can handle 100 requests for it. Let's assume that. Okay. Now, if it can handle 100 requests, that means we have 2 servers. So both of these 2 servers can handle 200 requests at a time. Assume we got 500 requests at a time. Then even in that case, if we have only 2 servers, both of them will crash. Okay. So then we can have auto scaling thing, like automatically add more and more servers. Or there's one more thing. What we can do is we can break this project into multiple servers, which we generally call as microservices. For example, earlier, even if this load balancer sent a request to this server, first server was responsible for communicating everything. Okay. If we take example of WhatsApp, voice calling will happen here, video calling will happen here, chat messages will happen here, status will happen here, everything will happen in this server only. And for other requests also, everything will happen in this server only. So even if both of the servers are capable to handle a lot of requests, all the requests are getting handled here only. So what we can do is we can break it into microservices. Okay. So first architecture was monolithic architecture. The second one is microservices architecture, which is a really common thing right now. Okay. Let's go into that. So what I did was, for example, if you don't focus on this image, you can think of WhatsApp. I mentioned voice service. There's a payment option, so payment service. There's a video calling service. There's chat service. So you can create multiple servers. One server responsible for voice calling. Second server responsible for chat. Third server responsible for payments. Okay. So similar to that, what I did was I created 2 servers. The first server is responsible for authentication only, making sure that the user is correct. It's not a fake user. And second is the server which handles a set of tasks for us. We can break this down into multiple servers also, but what will happen is this load balancer and this server will keep on repeating generally. Okay. But the point here is, now this authentication server, if earlier it was taking 10 seconds to process a request because of authenticating, rate limiting, and doing the operations that user want, now it just have to do 2 operations, let's say rate limiting and authentication, which can be done in 3 seconds, send to load balancer, and this another server will handle rest of the 5 to 6 seconds. By the way, seconds are a really huge unit. It generally gets done in microseconds, but it's fine for now. Okay. So that second server can process those 5 to 6 seconds of work, right? Now this server got freed quickly. This server got freed quickly. So that's the advantage of using micro services. Okay. For example, let me give you one example from restaurant thought process. There is a cashier, there is a manager role, there is a waiter role who takes your orders, or yeah, he's also a server, and finally is a cook. Okay, so there are five roles. Okay, now assume I'm running a very small kitchen in a remote location on my own, which is a really common practice. So I'll get the order. I'm the cashier. I am the manager. I'll get the order. I'm the waiter. Sorry, yeah, I'm the waiter. I'll give the information to cook, but I am the cook also, so I'll prepare that food also. I'll bring that food outside, give it to the customer. That customer will again in the end give me the cash. That's fine. It works. If there are two customers, maybe I can manage it. If there are five customers, maybe I can manage it. But if there are more than 10, 50 customers, for example, their timings will be different. Now, if I'm preparing food at that time, all the new customers who are coming, they won't know what to do because they are unable to see any person there. So how do we manage these kind of restaurants? We break down various roles. We introduce a person who will sit at the counter to manage cash or accounts. We introduce a person who will be managing things. We introduce a person who will be taking orders. We introduce a person who will be serving things. We introduce a person who will be cleaning tables. We introduce a person who will be cooking food. So all those roles are divided. Similarly, we are dividing authentication processes also, and another server is basically doing other operations also. So servers, we have divided into multiple parts so that each one is responsible for doing a fixed set of tasks. Okay, so yeah, that's a microservice architecture. Now, how will the request flow? First, user send a request to load balancer. That load balancer will send that request to authentication server. It can be first or second becoming of the load, and we as a user should not be concerned about that. That will again send to load balancer. Why we are using load balancer here? Because, for example, if we connect this first server to this server, we are not sure if this one is dead, then how will we know that this one has to connect with the second one? We don't know that, right? So load balancer is responsible for managing that load, right? If someone is dead, it will manage the load with the other server's help. So that's why these requests are still going to load balancers. And finally, we make sure that these requests go to databases also. Okay, great. Till this point, if you don't have any questions, that's great. If you do have questions, what are those? Do think of it, write it down, and let's see ahead if I'm able to solve those questions or not. If I'm able to solve those questions, that means you are thinking of something which is future, which should come next, and you are learning good things basically. Let's go. First thing, if we see this diagram and if we compare it with the first diagram where we had client, server, and database, this is way too complex. But the advantage of this is it is fault tolerant. Even if something fails, load balancer fails, passive one will become active. This server fails, the second server will handle it. This another server fails, the second server will handle it. So this is more available, highly reliable architecture. Okay, so the customers will be happy. Disadvantages, it is complex to manage, will require a lot of resources, will require a lot of developers also. The advantage of monolithic that we learned in the first part of the presentation was that it was very easy to maintain, not a lot of developers are required, but the problem is that it is very easily breakable. Once anything breaks, the entire server will crash. Okay, so we can see why microservices is preferred at some point and why monolithic architectures are preferred at some point. Now, what if the database becomes single point of failure? For example, if the client system fails, let's go to the first part of this system. If the client system itself fails, are we worried about that or responsible for that if we are creating the product? No, we are not. Why? Because this is their issue. If their device is not capable enough, if they have not charged it properly, that's their issue why it failed, right? And that has nothing to do with our website. Technically, they won't be able to open any website, right? So we are not concerned about that. We were concerned about server and database. So if the server fails, what we do? We introduce load balancer and multiple servers, basically convert that into microservices along with using load balancers. We did that. Great. But what if database fails? That's also our responsibility. So now we will have to fix this also. So this is the question here, that what if the database becomes a single point of failure? Because currently we have only one database. So now, generally there are two types of database, SQL or NoSQL. In this presentation, I am not covering about any of those things. Again, if you want those details, do let me know. I'm ready to create 20 to 35 or 5 hours of content, given we have good enough audience. Okay. Now let's see. How do we fix this database problem? Basically, we create something called this database cluster. The thought process behind database cluster is that we first thing is we divide our database into, let's say, n number of partitions. Okay, we call them sharding and partitioning. There is a minor difference between those two things, but what we can assume, very simple thing, is that if WhatsApp is a single giant database which keeps track of all its users, which keep track of all their payments, which keeps track of all their chats, which keeps statuses, which keeps track of all the voice calls, which keeps track of all the videos. Okay. Now what we can do is we can break this into 6 different databases. First database responsible for user related details. Second database responsible for keeping chats only, nothing else. Third database responsible for voice only. Fourth database responsible for video calling. Fifth database responsible for statuses. This is how we break it. Now, if they are very separate databases, if only one of these databases break, for example, voice databases failed. Okay, if that database failed, will other database get affected? No, other databases will still work. So you can still communicate in terms of chat. You can still communicate in terms of video call. Only the voice calling feature won't be available. Not the best solution, but still, it is not breaking your entire system. Correct? For example, if you are someone who has a car workshop, and your car workshop there is cleaning work related to car washing, there is a general service work, and then there is, let's say, third work related to engine modification. Okay. Now, if at some point you have only 3 workers, 1 worker for each. If third person, which is the engine modifier person, is not available for the job, he's on leave, what will happen? You can still run your shop. All the requests related to car washing during that day, you can take that. All the requests related to general service, you can take that. But you can say your customers, hey, today our engine modifier person is not there, so please come tomorrow, or we will inform you when he is available. Okay, so that's a general thing, right? So basically, we divided our database into multiple parts. We sharded it. Generally, we say that we sharded it. Okay. Now, what if, as I mentioned in the car related example, that we had 1 person for each? Okay, 1 person, 1 service. What if we had 3 person or 4 person for each service? Car washing, 4 person. Car modification, 4 person. Engine repairing, 4 person. Okay. Now, if one of them goes on a holiday or takes leave, will our system fail? Will we not be able to accommodate our users? We will be able to accommodate our users. We will still be able to do all those services. So what we did was we replicated the role of that same user. Same person who was doing the washing, we replicated it with 3 other people. So 4 people are doing the washing part. Similar to that, we do data replication also, which means that if a set of user details are in one database, we create another set of database similar to this entire database, okay, which has all the records and everything. So basically, even if one database falls or gets destroyed in some disaster, or somehow it's get destroyed, the second database will still have all the information. So sharding was to manage it. Replication is to make sure that we don't lose any details. Okay. There are still algorithms to all these things. Going in more depth, they can be like easily 4 to 5 hours of content on this. Again, not going in depth here. If we are using this, generally gets applied to sharding and partitioning, generally gets applied to SQL databases. Data replication gets applied to anything. In NoSQL, we use something called as consistent hashing. This is one of the practices. There are other practices also. But the point is, using consistent hashing, we are doing the same thing. We are dividing the database into multiple parts, and we are replicating it. Basically, making sure that even if one part of database breaks, we still have all the information. We still can process all the requests. Okay. The example is that if you are if you are focused on SQL, you can try out Amazon RDS, which is relational database service. And in NoSQL, this is one is famous, which is Amazon DynamoDB. Okay. So these are the Amazon services that I'm suggesting you. Okay. Now let's go to next. Brainstorming further. So what all things I explained you here is sharding and replication. Basically dividing it into multiple databases and then replicating it. This is exactly what. This one is first type of database. This one is second type of database. This one is third type of database. These are copy of one another. These are copy of one another. These are copy of one another. And this is called a database cluster. How they will communicate with each other, that's a separate thing. But the point is that even if server makes a request, even if one of them is down, we can still get all the requests and update all the requests, process all the requests. Okay. So now we have made it for database tolerant also. Like database now is not a single point of failure because we have replication in place. I don't have water, but my throat is dry. Okay, let's see. We still have a good thing to cover. Now let's pick one more thing, which is data. Generally, data is divided into two parts. One is text, numbers, all those kind of things, strings and all those kind of things. And second is static files, which is strings, sorry, which is images, videos, PDF files, Excel sheets, those kind of things, right? So we generally don't keep these static files, which are images, videos, PDFs, all these files, we don't keep them in database directly. Okay. We can do that, but we don't do that because it's not advantageous. Why? That's again, not going in depth, but it's not an advantageous thing. If you know the answer, please comment it down. I would be happy to communicate in the comments. But yeah, what we do is we use some sort of storage to store those static files, images, videos, different files. We store them in a, let's say, a folder similar to a computer. We keep them in a folder. We call them storage. Okay. In Amazon, we have something called as Amazon S3. It's a very simple thing. Yeah. So let's see how it works. It gets, there should be one more arrow that it should get connected to server also. Okay. So what we do is, this is the file storage. Basically, we keep all the files here. Now what happens is that, for example, I'm creating my profile. All the requests will come here. That request, now this server will make sure that, okay, I can create my profile. That profile has email ID, name, password, and my profile picture also. So what this will do is it will upload that profile picture to this server, file storage, get the URL of that file, get that information back in server, and now it will create an object or my file URL, image URL, my email, password, my name, and save it in the database. So that's how this entire thing communicates. Okay, this is a very simple file storage thing. Again, we can replicate this similar to how we did with databases and everything, right? Sorry. So we are done with this also. Now, what if the database queries are slow and repetitive? Why this point is important is because, for example, if I take example of PostgreSQL, at any given point, it can handle only 50 to 100 requests. Even if you do some form of optimizations, it will be able to handle only 1,000 requests maximum. Okay. So a PostgreSQL at a given point can handle a fixed set of requests only. Okay. So what we would want is either we can create multiple replicas, but if we have 10 million, 1 million, let's say, users at a given point, we will need easily 1,000 servers, 10,000 servers actually. I'm not fully sure the math is, but the 10,000 database replicas for that one type of database, right? That would be way too much. Now, sometimes what we have is we are getting repetitive queries only. Okay. For example, if I'm in my Gmail, if I go to my delete or if I go to my spam folder, it will generally have same details only. Inbox can change day to, but these things won't change very frequently. Okay. So I'm getting the same data again and again, again and again, again and again. So if I'm doing that, in that case, what I would want is, why not save it somewhere other than the database such that I can access it quickly. At the same time, I don't have to make request again to database. So our database will get less request compared to what used to get earlier. At the same time, it will be able to manage load easily. So for that, we have something called as caching. Okay. Generally, it is an in-memory thing. I can go in depth of it here. So database is something we store on disk. Okay, so even if you turn off the disk, it will still have that storage. If you turn it on, you can still read it. Okay, in-memory thing is that it's sort of RAM. So until and unless you keep your system alive, you can store some information in it up to a certain limit. It is not unlimited. It has very limited storage. But the advantage is because you are not saving it on disk, you are saving it in memory. Reading from in memory is way much faster compared to reading it from disk. Okay. So if you are reading it from in memory, obviously it will work faster. I can give you one very simple example. If you have used CD players in laptops in like 5 to 10 years back, opening that CD player would take time. But if you open a folder which is already in your laptop, it would get open quickly. So that's in-memory thing. You can assume up to a certain extent. It's not the perfect example, but up to a certain extent, you can assume that that can be treated as in-memory and that is a disk storage. Okay. Technically, that's also not in-memory, but that's fine. Okay. But the main point is that caching is in-memory. It has limited storage. If the system fails, it will get erased completely. Okay. And advantage is that it is really fast to access. Okay. Some common examples are AWS, Amazon Elastic Cache, and Redis. Okay. Now, how do we use it? We use it just before database generally. You can use it anywhere actually. You can connect this distributed cache here also. You can create cache here also. You can use it anywhere technically. Okay. But I've used it in a simplified way just before the database. Okay. So how will it work is first user is coming. He doesn't have any background on this product. They haven't used this product in past. So they will make a request. They will authenticate themselves. They will go to the server and they will see whatever information they are trying to see is available on distributed cache or not. Assuming that information is not available on the cache. So what we say is that it is a cache miss. We have missed the cache. Okay. So now this cache, what this cache will do is it will communicate with the database, get that information and save it in cache and send it back to the server via load balancer, back to the authentication server, via load balancer, back to the client. So client has received that information. And at the same time, we have saved it in cache. Now, second user comes in, that person is also requesting for the same thing. Okay. So that request will go back to the server, another server. Now that another user will request that information from distributed cache. Once they request it, will we find that in the cache? Yes, because we have saved it recently. So we say that it is a cache hit. Okay. Now in this case, it will fetch that detail directly from this cache, send it to server, and then to client. In this second case, we did not use the database. And that's how, out of the two requests, only one request was processed by the database. So we have reduced the database load directly. Okay. One very common example of this is there is some trendy post, okay, or trendy tweet, okay, which is going really viral. So what news agency, as in these product companies will do is that they will save their information in distributed cache. Okay. Now, whenever thousands of users make the request, it will go back to the cache again and again and fetch the detail again and again. And the database cluster will not get hit or bombarded with multiple requests. And therefore, the workload of this database will reduce. Okay. So that's an advantage of cache. Now, as I mentioned, that it has very limited memory. For example, it can store 10 news only, for example. So how will we make sure that if the 11th news comes in, can it save to the database? No, it can do only 10. So how will we make sure that which one we delete? So there are various algorithms to it. Again, not going in depth here, but one common thing can be that the news which has been least visited, okay, the news which has been read least number of times by various users, we'll remove that because it is not getting used by many users. We'll remove that and I will save the next entry, 11th entry that I want. So again, the cache is full, but at the same time, we were able to save the new entry. At the same time, we were able to remove one. This is called cache eviction policy. There are multiple types of policies. I think again 5 to 7 types of policies, or you can create your own custom policy. It's completely fine. But the point is that it can be covered in next videos. Now, how to make system fast and efficient? Okay. In this entire system, what has happened is these load balancers are geographically located. Let's say they are located in India. Okay. This server is located in India. Load balancer are located in India. Server located in India. Now, someone who makes a request from India, they will get request very fast compared to someone else who makes a request from, let's say, USA. Okay, because geographically they are at a farther distance from this entire system. So how can we make better for this? For that, we use CDNs. These are called content delivery networks. They are basically, you can see Amazon CloudFront and Cloudflare. Okay. This is a CDN. We generally connect it at client side, but I'll show you one image. Okay. CDN image. Let's see images. This one. open copy image address. Let's see. Okay, so this is the original server. You can see orange one. Then these are CDN servers. This first one is CDN server, second one, third one, this, and the users. So what happens is that we have one origin server. We can keep it multiple also, but generally we keep only one origin server, and then there are various CDNs across the globe. Okay, so India has one CDN. Uh, Another one is in, I don't know what this part is, but this is way beyond Canada, but let's say that this is in Canada. Another one is in South America. Another one is in Africa. Another one is in, I think, Madagascar. Another one, okay, we have only these things. Another one is in North Africa or those kind of things. Okay. Now, if a person makes a request from India, if that user was here, they will first make a request to this CDN, this server. Okay. They won't make a request here, which is in Africa. They won't make a request here, which is the original server in USA. They won't do that. They'll make the request to this CDN. This CDN will make the request to, if the user is first time, that CDN will make the request to our origin server and get that data and save it here and provide that to the user. Now, you can assume that this is similar to cache in some way. Okay, cache was also doing it that if this was the database, cache was making sure that database doesn't get overloaded and making sure that using cache we can communicate faster, right? So CDN works like that. But the main thing about CDN is it stores generally, you can do dynamic data also, but generally it stores only static files. For example, if you are opening a website, it will have some logos, it will have some images, it will have CSS files, it will have HTML files. So those details generally don't change that frequently. So this CDN will store all those static images. Those data itself can take 1 MB or 2 MB, which is a huge data. It's not a short data. Okay. So that entire data will get saved in this CDN so that any user can quickly access it. Okay. And once I made the request, now my friend who is from Bangalore makes the same request. They won't have to go to this original server. They will just have to get it from CDN and they can quickly access it. So now other users will get it quickly. Okay. Now similarly, if someone is from South America, they won't make request to India. They will make it to their CDN, and that CDN can make request to original server if they want to. Okay. So CDN makes sure that you get information from a server which is geographically near to you. Okay. Think of it like this. There are various supermarkets from where you can buy Red Bull. Okay. Now, you won't go to Red Bull's headquarter again and again, right? Actually, you won't go to their headquarter in any case. What that Red Bull company will do is they will create distributing centers across the globe, right? So they have distributors in Udaipur, in Rajasthan, at India level, they will have distributors. So those distributors will keep on buying from the Red Bull company, store it there, and we as a customer will go to that particular distributor or that particular shop. We won't go to its original server, right? If, for example, that shop doesn't have that Red Bull or particular flavor that we want, if we make enough requests, what it will do is it will inform the company, hey, I want this Red Bull. Our customers want that and we don't have it. So that original Red Bull company will again send that set of Red Bull packages to the shop or the distributor, and now we can again buy from them. Okay, so that's how we made sure that we are buying Red Bull from geographically near location. That's the exact same thing CDN works. Now, to be honest, I've come up with this Red Bull example right now. I haven't thought of it in the presentation. I haven't thought of it earlier anywhere. Now, this is what I think teaching should be. And if you like this particular example, do let me know if this made sense. Okay, I generally try to keep things around those realistic examples only. So CDN is something which stores static files generally to make sure that some data which is really repetitive can be stored locally so that the users can get fast responses. Okay, now let's go back to the presentation. Okay, so CDN is delivers and caches content based on geographical location. I explained you. Mainly caches static content like images, videos, files, front-end code, etc. Okay, I explained you that. Now, there is one thing called analytics, tracking, and monitoring. So, for example, even if I am making all these movements, even if I'm adding some product to the cart in any website, deleting it, all those things do get tracked. Why? Because for companies, it is important. Like if I'm adding MacBook Pro from Amazon in my cart and then removing it, I have not bought it, so company had not made any money. But company would like to know why they deleted it, well, so that they can analyze whether their pricing was high, whether the product was fake, what was it. Okay, so these are very small analytics. There can be multiple analytics related to performance, health, session times, a lot of things. But these are analytics. Do they anyway directly affect user? No. Indirectly they do, definitely, but directly they don't affect user. Okay. Users don't need to worry about whether companies are taking what type of analytics, tracking, monitoring. They are taking your location also certain up to a certain extent. They are taking your IP addresses, they are your internet speed, all those things. We don't care about those things. Users don't care, right? But the companies do. Now, for these storing these kind of things and managing these kind of things, we have something called as SQS in Amazon, but generally it's a term called message queues. Kafka is one example for that. SQS, Amazon SQS is another example for that. So let's see that. This was our original server. Okay. Now, what this original server has is this. I mentioned that on the client side, we are tracking analytics also. We'll get that analytics, send it to CDN, send it to load balancer, send it to authentication server, send it to another server, or you can connect this entire queue. This is a message queue to this authentication server also. It's completely fine. Now, those analytics are something we just want to save. We don't want any feedback on that or anything around that, right? Now, those analytics are generally huge in number, and we have very limited servers. Okay, my internet gone, so it will be a big problem. Let me switch internet. Let's see. Okay, I hope this works. Otherwise, my whole video will get basically damaged. Okay, let's see. So all those requests, what we do is we keep on getting those requests. Do this server needs to do any extra processing on that? In sometimes it might be, but generally we don't do any extra processing in this server. What we do is we dump that information quickly to this queue. So message one will come, message two will come, three will come, four will come. Now this server, I mentioned that it has limited processing power. Okay, obviously we can scale it, but generally we do keep it limited only because we want this to, it's fine if we run it 24 hours, but we don't want it to get all the workload at one single point of time. Okay, so what we'll do is we'll create a queue such that all the requests can be maintained here, and as soon as this server is free, message will be sent to this, or the request will be sent to this analytics monitoring server, and it will process those things, add to database, do all the operations that it wants. So first message came in this queue, sent to analytics monitoring. Great. As soon as this and second request came, but it is still stuck on the first message. Third request came, it is still stuck on the this message came, it is still stuck on the first message. Now, as soon as the first message will get finished, will get processed, it will take the request for second message also. And that way we are able to manage the queue very easily. At the same time, we are not using multiple servers, we are not increasing our cost. Okay. So message queue is something which can be really helpful. This is one example that I gave you. You can use it for various reasons, other purposes also, but this is a very general purpose example. Okay. And now you can see there is one more thing. These are analytics related database. We don't worry a lot about these directly. They are not related to user directly. So what we do generally is that we create a separate database for them and save it there. We don't save it in main database. So generally a project have multiple database. Payments will have separate database cluster, I'm saying. Okay. Chats will have its own separate database cluster. So there are various servers, various database, various CDN points, various load balancers, various distributed cache, various message queues. So it's a very big deal. But the point is, this is a very basic overview. Now let's go ahead. Quickly, let's revise. Okay. We started from the basic thing, client, server, database. It was a monolithic architecture, which means that if any one of the database or the server failed, everything failed. So we focused on the server. Basically, it was a single point of failure. So how we fixed it? We introduced another server. Now, if we introduce another server, how do we make sure that the load is balanced and they are able to get equal number of requests. We use load balancer for that. It will manage those things. Okay. It can use round robin algorithm, least connection algorithm, a lot of different things. We are not going in depth of it. So second thing was load balancer. Okay. Now that server still is processing a lot of things, right? All the things are getting processed in one server. So we break those into multiple servers also, which we called as microservices, created authentication server and another server separately. So that was called microservice architecture. Third thing. Okay. Now after that, we thought, okay, database is still one. So if that database fails, crashes, entire thing will crash, right? Or entire thing will fail. So how do we fix it? We do sharding, partitioning, and data replication. Okay. So based on these three things, we created database cluster. Okay, great. So you learn terms like sharding, partitioning, and database replication. Okay, it again has a little different set of theories, algorithms, and all. Now we did that. But again, our processing queues were slow. Sorry, entire process was slow because database do take time. They don't have unlimited number of concurrent users. So how do we manage it? If there are any repeated queries, we use cache for that. Cache is basically something which can be accessed very easily. A very common example of this is if you are going to the shopping market, you will find dairy related product very easy to find because they are used by almost all the population. But you'll find products which are used once a month at the back of the counters. Okay, so there are various distinctions. It's not the best example, but that's how caching works. That you try to provide something which is very easy, which is very important and is repetitive. It should be really fast to process that request. Okay, so cache stores some information so that same request can get same data again and again. In that case, database doesn't get overloaded. Now cache has limited memory, so we use cache eviction policy to clean it up regularly. Okay. Now after caching, we also learned one thing earlier before cache, which was file storage. For that, we used Amazon S3, which basically we used it to store images, videos, files which are user related, not the code related, but the user related thing. Okay. Now, after that, we thought, okay, we have used cache or a cache cluster, but another problem with cache database, distributed cache is that, sorry, after distributed cache, another problem was that if someone is making request from India and someone is making request from USA, their times will be different. Okay. So to fix that, we use CDN, which basically makes sure that you get a request processed from the nearest server from you. Okay. I gave you the example of Red Bull. Think of it. And based on that, map out how the CDN was working. Okay. After CDN, we thought, okay, there are some form of data which are not related, which are related to user, but are not affecting user in any way, like the analytics or the internet speed or the laptop configuration, all those things, right? So for all those things, we use message queues so that we can store those information in queue and process it at our will. We don't have to worry about it. Okay. So this was the basic architecture thing that we learned. I hope you like this video. I know this is way too much information, but the point was that we started from something very small and went all the way to something very big. We can still expand this to a really big system design problem, but like designing the WhatsApp, designing the Uber system, designing Tinder, designing YouTube, all those things. But right now, this is the basic overview from my side. If you're interested in more in-depth content about high-level system design, do comment down below. Do let me know. You'll find an option to super thank or thanks, which is basically a way to support this channel. Do make sure that you can do that. Along with that, you can join my channel, basically become a community member. There are various tiers to it, so that you get more exclusive and premium content easily. Okay, that's all for now. I would appreciate if you can leave some feedback because it required a lot of efforts creating the presentation, giving one presentation, and then creating another video. So do leave a like and let me know your feedback and share it with your friends. That's all. Thank you. Bye bye.